Today we are hitting on 2D vectors and file I/O. We will spend most of the time talking about 2D vectors because I think file I/O is pretty simple, but it will get its due. And let's see, how do I want to do this? Okay, well, let's start with actually just showing you what 2D vectors look like, and then we'll take it from there. So, a 2D vector looks a whole lot like a spreadsheet.
And it's not coming up.
It's not coming up. Thank you. There we go. Okay. Looks a whole bit like a spreadsheet. So, in C++, they start their numbering, going up to whatever we'll have, say, one that is length 10. And then each one comes out on its own like that. Let's say it goes up to 4 in this case. And the way you access these things is through row first and then column. So let's say this was a picture, because you are doing the PGM lab and you could use a 2D vector to represent one of those pictures. So let's say that we had called it, and the way you declare them is you say vector and then vector, and need to erase here for a moment. So you need a vector, vector, int, blank space. So that's how you declare it. And when you declare it, you need to make sure that you have a blank space between your two things. Otherwise, it might confuse the compiler. If you just, so let's actually try to do that. So, let's get rid of this one. Wow, vector, vector everywhere. Okay. So, let's try to declare one where we don't put two spaces, or a space between these two right here. So it says error, a space is required between consecutive right brackets. And does anyone know why that might be the case? Yes. Otherwise, it will read it as cout. Yep, this looks like the cout character to C++. So you need to put a space in there. Okay. So you've already seen in labs 1 and 2 two times when you might want to use a 2D vector. In lab 1, you might have wanted to use it for the checkerboard. If you could have stored the checkerboard in a 2D vector and then printed it out, it would have simplified your program. And in lab 2, if you could store the PGM file in a 2D vector, it would simplify things. In fact, for the vflip program, that's what you will be doing, is you'll be using a 2D vector to store the file so that you can vertically flip your picture. Okay. So 2D vectors, they come up a fair amount. Obviously, spreadsheets are another example where the underlying data structure could easily be a 2D vector. And going to basically go through an example of how you set up 2D vectors. And this is going to be very similar to the structure you use for VFlip. So it's something that you may want to, at the end, take a picture of, copy down. It's also, I am videotaping it. So I'm going to call it pic.cpp. And let's say that what we are going to do is read a 5 by 6. In fact, let's not even do that. Let's say that we're going to read the rows and columns. So we'll read the rows and columns first, then we will resize our vector to the appropriate size, then we'll read in the values. Okay? So we start with our usual things, and we have to include a vector. And actually, because we just got through with command line arguments, I'm going to use command line arguments. So I'm going to assume that the rows come in as command line arguments. Okay? So I am going to need to declare a rows and columns to hold the rows and columns. And I am going to use pseudocode. So don't write this down, because I'm going to start with pseudocode, and then I'm going to build it up to the right program, okay? Because that's the way I think. I find it easier to incrementally develop things and not have to do all the picky details. So initially, I'm just going to say that rows is equal to argv1 and that columns is equal to argv2. Now, that's not going to work. This is pseudocode. Okay, I'm going to go back later, and I'm going to fix it so that I actually assign integers to rows and columns. I'm going to have to, those are strings, they're going to have to be converted to integers using an iString string. But I wanted to avoid messy details and just do the high-level logic first. Okay, so once I have that, I'm going to need a vector, 2D vector, and it's going to be a vector events. And I'm going to call it picture. So one thing I could try is to resize it and say that it should be equal to rows and columns. Do we think that's going to go down well? Doesn't know it's a 2D, very good. And if you give two arguments to resize, the second one is the initialization value. So in fact, what it would do is resize picture to have that number of rows, and it would assign the value of columns to each of those entries. Okay, not what we want. Okay, what if we try this? Think that will work? It's also going to be a big failure. Okay, what it will do is it will first resize picture so that it has that number of rows. And then it will say, oh, you want to resize it again so it has that number of columns. So in the end, you'll have a vector with that number of columns. That is, the first, let's say, rows is equal to 3 and columns is equal to 5. The first resize will give you a vector of size 3. And then it says, oh, you want to resize it again. Now you want to make it 5. So that will be the effect. It's as if you had written it as that. Okay, that makes it clear what's going on. The first operation is simply essentially a no-op. It's as though it never happened. So that doesn't work. So we're going to have to use a for loop. Okay? So what we're going to do is we can resize the first part of it to have the right number of rows. So in this case, we could resize that. But now what we're going to have to do is we're going to have to resize. Right now, each of the vectors is 0 length. What we need to do is go through and for each one resize the vector so it has 5 columns. And the way we do that is with a for loop. So for I equals 0, I less than picture.size, I plus plus, we are going to say picture I dot resize to be columns. So for each row, we resize that row to have the right number of columns. So one by one, we're inflating. One by one, we inflate each row. Okay, like blowing up a balloon. Yes.
Can you use dot at to do the same thing?
Yes, so good question. In fact, we probably recommend that instead of doing it this way, you actually say dot at so that you don't run past inadvertently the end of the array. So in fact, this is the safer way to do it. Okay, now I know I haven't declared everything. Again, I'm doing it high level at this point. So now I would like to read in my picture, and it's pretty easy. So I'll say for r equals 0, r less than picture.size, r plus plus, so r standing for rows, and then for column equals 0, column less than picture r dot size.
Don't forget to declare them, actually.
I won't. I'm just doing it at a high level right now. Thank you. Okay, and again, I will go back, use the at, and I just say cin into picture.at r.at c. And that should read pixel by pixel into my picture. Yes.
Instead of doing picture.size and picture.add.r r.size, could you just use row and columns?
Yes. The question is, could I have just used rows and columns there? That would have been fine. I have no problem with that. Okay. So just to show, I know picture.size I know to be rows, and this one I know to be columns. So this would work equally well. Okay, now I should probably also print it out at the end. So I'm going to copy this set of code right here because it's essentially what I need, paste it, and then I'm going to modify it so it prints it out. And in case you all haven't seen this command, what I'm going to do is type 5YY. You can't see it, but at the bottom you see 5 lines yanked. This is in Vim, and if you type a number followed by YY, it will copy that number of lines into the clipboard. So you're used to copy and paste. The YY command is how you copy something into the clipboard in Vim. And then to paste, I just go down to where I want to paste and I type P for paste, and it pasted in those 5 lines. Okay? Now, instead of printing out what I want to do, or reading in, now I want to print out. So I'm going to C out. And after each line, I want to output an inline character. And I'd like to put spaces between each of them. So I'm going to do something that's a little bit dangerous. And I'll tell you why in a moment. But for the time being, I'm going to put a space after each one. Okay, so that should print it out. So I should comment, print out the picture, read in the picture. Okay, now, a couple things. I have to come back here and actually clean up this code for reading in the rows and the columns because these are C style strings, they're not integers. So I am going to add a iString stream, and I will stuff argv1 into that string stream, and then I will read the buffer into rows. Then I will clear the buffer, stuff argv2 into it, and again read the buffer into columns. So that should convert my 2 string arguments into integers. Now I'm not checking right now, so ideally I would add some code to do error checking, but initially when you're developing a program, it's often just a good idea to assume it's error-free, the input is error-free, and then later you can go back and clean up the errors. So for the time being, I'll assume this is all good. I have to include string streams up here with an S stream. And as someone pointed out earlier, I need to declare my variables. So I have an I, an R, and a C. I think that takes care of it. Okay? We liking this? Let's give it a try. So I'll move this over. Get a new window. Is where you, oh, look at that. Perfect compilation. Okay, we'll make it simple. A 1 by 1. Start simple in testing. Enter 3. It printed out 3. That was pretty easy. Now let's have a one row with 5 columns. Okay, 1, 2, 3, 4, 5. That looks pretty good. Okay. Actually, now I'm going to create an input file. So I'm going to create a 3 by 5. So that's a 3 by 5. So now I'm going to say 3 rows by 5 with pic.txt. That looks pretty good. Now, I should be a little concerned when I always use the same number. Maybe Cin is jammed or something before I totally celebrate. So now I create some more random stuff, and I'll run it one more time. That looks pretty good. Okay? Now, there is an issue here that will come back to bite you if you do it in your programs, and that is the way I got a space between each of my columns is with this printing a space at the end. There's an issue. That issue is it actually prints an extra space at the end of each line. Right? Dr. Planck in his scripts is very careful not to do that because that space at the end of the line really shouldn't be there. Okay, the line really should end with this last pixel. And this comes up a lot in printing, where you really don't want to print anything after the last character on the line. Okay, so we need to fix this. And you can't do this in your labs either because you will come to grief. So what I really want to do is print this first one, and then after it, I will always print a space and then my value. A space and then my value, a space and then my value. And you might say, well, why not do it the opposite way? Why not just print the value in a space, a value and a space, and then when I get to the last character, I simply won't print a space? That's a little harder simply because you're maybe always having to test to see whether you've reached the last character or not. Whereas what I can do is do what's called a priming write, which is to write the first print the first pixel, okay, and then starting my index at 1, because I've already printed the first pixel, I always print a space and then I print the value. Okay, that works very nicely. Okay, the first write, which occurs here, does not have any space in front of it. Afterwards, we have spaces in front. Okay. We call it a priming write. Has to do with being back on the farm. Anyone grow up on a farm? Okay. Remember priming the pump for a well, or did that? So sometimes to get well water up, you start by taking the handle, and before there's actually water coming out of the well, you have to pump the lever a few times. That was called priming it. Okay, so this is kind of priming by starting the writing process with the first write. Okay, there is another way to do it. I don't think it's as elegant. I prefer priming writes, but you're okay to do it the other way. And that is to check to see whether this is the first value or not. Okay, so what we could do instead is say, start it at 0 and say if C is not, or C is greater than 0, then we will C out a space Okay, this works fine too. So if C is equal to 0, we don't want to print a space, otherwise we do. That works just fine as well. If I run it, should always run it, not just assume something's working. Yep, works fine. Okay, now to be clear, I'm not going to add the code here, but there's a whole host of error conditions that I should be checking for with the command line arguments. In fact, let's think about what they are, even though I'm not going to go through and do my testing. What are the possible errors with the command line arguments that I should check for? So potential problems with command line arguments. Some are missing, so I will say too few. Okay, so that would be argc not equal, okay, or too many. So we should have, the test would be if argc is not equal to what? 3, because there's 2 command line arguments plus the one that C++ automatically gives us. So one check is to make sure that the number of command line arguments is exactly 3, and if not, we print out an error message. Okay, what is another possible problem with the command line arguments? Wrong input type. Okay, so must be integers. Okay, so check to see if they are the wrong input type. Okay, and there is one more potential problem. Negative numbers are bad.
And zero.
And 0 is bad. Negative numbers are bad and 0 is bad. So in fact, what we want are we want positive numbers. Okay, and there's another one. And this is something that is easy to forget about. What is another? There's one more, and it's subtle. We actually have too many up in one, so too few or too many. I thought for a moment you had it. There is something along the theme of too many.
I mean, theoretically, you could overflow the amount of memory.
Yes.
So.
Yes, you want to avoid having some hacker try to overflow memory or do something else by giving you an absurdly large number for rows and columns. So the fourth thing that you should do, and we don't make you do this check in our labs, but this is something you need to be careful about in the real world, is limit the size of the rows and columns. Okay? In the real world, what people often do, it's a somewhat different situation, but they will say, well, I don't know how big the picture is, but I bet if I just make the vector, or they'll actually use an array, if I just make the array big enough, like say 1,000,000 and 1,000,000, I'll be okay. And hackers take advantage of this all the time by inputting a string that is much bigger than that. And it is called a buffer overflow attack. Because in effect, they overflow the amount of memory that has been assigned, and then a very clever hacker who knows something about the architecture of the machine can actually cause the overflow to go into areas where sensitive areas, and start to execute machine instructions that should not get executed, or look at data that should not be looked at. There's all kinds of things that a very clever hacker can do with what is called a buffer overflow attack. Okay, and it always happens because people think that they've accounted for the maximum amount of memory that can be allocated, and they haven't. So in the real world, you would also want to have a test that checked to see how big the rows and columns were and would print out an error message if it was too big. Okay? Not an issue with our lab, but could be an issue. So these are the 4 error cases that I would want to check for if I were writing code. That's a lot for 2 measly arguments. But if you're not careful and do that kind of stuff, things will go off the rails. Okay? So this is your basic way that you'll start doing the VFlip lab. Okay? A lot of this code here. Now, you won't be using command line arguments for VFlip. You'll have to read that in off as standard in, but and you won't need to use a string stream. You could actually check it with cin. But the rest of this is pretty much on target, and this is very important, the way that you resize the vectors. Okay? That's how you can use a resize on the outer row, but then for each row you have to use this inner loop here to inflate the row properly. So questions about that? Yes?
How do we exactly check to see if the command line arguments are actually integers?
So if it fails, so you try to read it in, okay, and if it fails, that's the, so you say if not, then it failed. I'll print it to C error. And it's often a good idea to print out what the bad thing is. Rows is not an integer. Okay, so attempt to read buffer into rows. If it fails, then you'll come in here, print an error message. Okay, we can check that out. Compile it, and I'll run it with some Brad5. Okay, and rows, and I actually shouldn't have said rows there, because rows is wrong. It's argv1. Okay, rows Brad is not an integer. Okay, if I were reading it in with cin, it'd be the same thing, except I'd say if not cin into rows. Other questions? Okay. Now for a subtle thing, but it needs to be said. When you are doing something, such as reading in or processing a vector, let's say that I was going to sum up everything in this picture, okay, and take an average. So I will change it so that I'm doing a sum. So if sum equals 0, int for the time being, I'm just going to sum it. Okay, so that's summing it up. It's very simple. For r equals 0, I go for each row, and then I go through each column. There's another way I could do this. I could go through the columns first. So I could move this inner loop and make it the outer loop. This is equally correct. Okay, now what we're doing is, if we look at this diagram here, is we are starting here and we go and sum by column, come back up to row 1 and sum down the second column, come back up and start summing down column 2. So this is equally right, and yet you never see code written like this. Why? Okay? Pardon?
It's inefficient.
It's inefficient, and the reason has to do with something called cache. So when you buy a laptop, you may notice that it says level, like 5 megabytes or 32 megabytes of level 1 cache, 128 megabytes level 2 cache. There is cache memory that is very fast sitting right on the CPU chip. It is faster than your normal random access memory. Okay? When you have today's computers try to pre-read stuff, they try to anticipate where memory is coming from. The way a vector is laid out actually in memory is not as this table, but it is actually laid out in one long line. So the first row would be there, then the second row there, then the third row like that. So it's laid out in what is called row major order. This is called row major because the rows are being stored contiguously. So when you go through it, row by row, you are sweeping through this thing, and every number you read is contiguous to the previous one. And what happens is, as the computer is reading the vector, it actually preloads stuff into cache. It will often, for example, it could preload one row. So when it goes through in row major order, when you read the next value, the computer is used in essence predictive or speculative logic to preload the rest of this row. The rest of the row is already in cache, and so the next access is very fast. The next access after that is very fast. Okay? Let's say that instead of doing it in row major order, that you do it the way I have it here, where you're going column by column. Now what happens is your first access is right here, but your next access is right there. This causes what is called a cache miss because the computer was thinking your next read would be right there, but it wasn't. A cache miss causes the computer to have to say, okay, I need to go out to random access memory and get that value. Meanwhile, it either spins its wheels doing nothing, or it puts your process aside and goes to another process. Generally, it won't do that, but it will spin its wheels for a moment, waiting for that next piece of information to come in from random access memory. These cache misses result in a less efficient program, since the CPU is temporarily stalled waiting for the information to come in out of RAM. So that is the reason that you always see loops written in what is called row major order, like this. The outer loop is for the rows, the inner loop is for the columns. And you're saying, oh, how can I get the computer or C++ to store the vector in column major order? You can't. That's just the way the compiler lays out 2D vectors and 2D arrays. It lays them out in row major order. Okay? Subtle but important. Just out of curiosity, did you go over things called cache misses in CS130? Okay. So you know that it can slow things down. Okay. Anything else I wanted to say with vectors before? Okay. Go over that. Go over non-rectangular 2D array vectors. Yes. Okay. So we do not have to have square vectors or 2D vectors. They could be in some other way. So for example, let's say I wanted to have a 2D vector that shows the distance between cities. Okay, so let's say four cities. And I'll just say Atlanta, Knoxville, which is TYS, Nashville, I have no idea what, and Memphis. And down here, Atlanta, Tyson, Gee Airport, Nashville, Memphis. So this is the mileage between the two cities. Okay, so from Atlanta to Tyson is maybe 180 miles. From Atlanta to Nashville, maybe 120. And from Atlanta to Memphis, maybe 360. Do I really need this entry right here? No, because I already know that it's 180 if I just do Atlanta to Tyson. Okay? So I do need to know what the distance is from Tyson to Nashville. Okay, maybe it is also 100, let's say 100, and from Tyson to Nashville, maybe 300. Then I get to Nashville, and all I need is Nashville to Memphis. Maybe that is 180. And when I get to the Memphis line, it's not even necessary, right? So I really don't want to have to fill up this entire thing. And I don't. I probably want to fill up the lower half rather than the upper half. So what I really want to say is 180 from Tyson to Atlanta. From Nashville to Atlanta is 120. From Nashville to Tyson is 100. Memphis to Atlanta is 360. Memphis to to Tyson is 300. And Memphis to Nashville is 180. And now what I want to do is get rid of the top half. So what I don't need that's all I need. Okay? And I'm allowed to do that. So in this case, what I would do when I wrote the code is when I did my resizing, I would probably say dot resize instead of coms, it would be probably I plus 1 because I want the number of columns to equal whatever the row number is. So here, this is the first row. It should have 1 column. Row 2 should have 2 columns. Row 3 should have 3 columns. So picture that dot at I dot resize I plus 1.
It'll still be I, because at the 0th one it'll be 0.
Right. So since we use zero-based indexing, we would still have Tyson being at 0.
Well, but isn't there Atlanta above it? Or I guess There's
There,
a row of zero.
but there is no. There's in essence no. There was nothing in this row. It was empty. So I'm just eliminating it.
Skipping it. Okay.
I'm just skipping it. Now let's see. I do think I have an issue. May not have enough information here. So Tyson to Atlanta. Then I get Nashville and I have to tag. So I do have actually, I think I need one. I don't have Tyson to Nashville.
Yeah.
There are 6, okay. Feels somehow wrong, but it's not. Okay.
There's only 6.
Yeah, there's only 6 numbers. Okay. So here's another example where I don't want a rectangular array. Let's say I have a bunch of student exams or homework assignments, but it's random how many homework assignments the student completed. So all I'm going to get is the student's ID, a numeric ID, and their exam score. So let's say my input looks like this. Homework.txt, student 0 got a 58. Then there was a homework assignment where student 1 got a 73. A homework assignment where student 5 got an 83. Homework assignment where student 0 got a 81. An assignment where student 4 got 53. An assignment where student 1 got 85. So what I'm doing is entering the student ID and the score they got on that particular assignment. And what I want to do is I want to store with each student all of their assignments. Okay? Well, 2DVector is a good way to do that because the student IDs, in this case, I'm conveniently making them low numbers. So what I would do is initially the first one comes in, so 0. Move this further out. So initially entry 0 would have 58. Okay, then 1 would come in, and it would be 73. Now, a bit of an issue, 5 comes in, and obviously we're not big enough, so we'd have to resize so that it's big enough to hold 6 entries. So 0, 1, 2, 3, 4, 5. So now 5 has 83. Now we read 0 and we add 81 here. And we read 4, so we add a 53 to 4. Then we read 1 with an 85, we add 85 here. So you can see some of our vectors don't even have any size. Actually, this shows, I'm showing it as though it has a entry, but it doesn't. It's really size 0. This one is also size 0. Okay? So all I'm doing is adding homework assignments one at a time, and I'm not going to have any kind of rectangular vector. So how do I write this program? Okay, let's do that. Let's call it scores.cpp. So I'm going to have a vector of ints of, call it students, and I will have to read the ID, so student ID and student score. Okay, so I'll say while seeing into student ID and student score, I want to add that score to the right part of the vector. So the first thing I need to do is see whether that entry exists yet. Okay, if I just, at this point, if I try to say students.@studentID, that might get me an exception because right now that vector for the first, when I first start, is 0 by 0. Or when I read in that student number 5, I didn't have enough entries. So the first thing I have to do is check to see if the current size is big enough to handle it. So if student size is less than student ID, okay, and you always have to be a little bit careful here with your, because we're using zero-based indexing. So let's say, let's check it with student ID 0, the size is 0, and the student ID is 0. So is 0 less than 0? No. So actually, what I'm going to do, I should have finished the logic. I am going to okay, so the logic actually is if I'm not big enough. So what I want to say, if the vector is not big enough, resize it. Okay, so it so happens that if the size of students is less than the student ID, so let's do one where the size is 5, so it goes from 0 to 4, and the student ID is 5. Is 5 less than 5? Let's see. I don't like the way I'm writing this logic. Can I make it more obvious? Let's see. I think it might be more obvious if student ID is greater or equal. This is going to be more obvious. Think so. So if the student ID is greater than or equal to students.size, then we're going to have to resize it. Okay? Because we start with zero-based indexing, if the student ID is equal to the current size, it's no good. Okay, coming back here, if we come with student ID 5, and let's say the size of it was 4, or was currently 5, the index would only go up to 4, right? So we have to actually say if the student ID is greater than or equal to students.size, we resize to student ID plus 1. Okay, now, once we have it, we can simply say students.at_student_ID.pushback student score. Because we're always adding to the end of the vector. So pushback will extend the appropriate vector by one entry. That can be also hard to see. So this first thing, students we're finding the right row. Then when we have the right row, we're saying dot pushback the student's score to extend whichever vector by 1. Okay, if it was size 0, so when we resized 5, or the thing to be 5 initially, the size of its vector was 0. So the pushback is then what gave it its first entry of 83. Does that make sense? Okay. So you do not need to have always rectangular or square vectors. They can be jagged, like in this case. Okay. That's enough for 2D vectors. We will now move on to file I/O. And I think it's pretty, should get rid of this. No, we'll do it right. Okay. Okay, so few things. You read most of it. If you want an input file, it is an IF stream. If you want an out, so is input. And if you want a output file, it's an OF stream. Okay, and if you include it, you include F stream. Then the important operations for an IF stream, the important operations are dot open with a file name, the greater than operator that reads from the file, and dot close, which closes the input stream. And it's easy to forget the dot close. Normally that doesn't hurt you because the file system will automatically close all files when the program exits. But there are limits on the number of open files you can have at one time. I think in many cases it's 256. So if you have a long running program and have a lot of files open, sometimes you do run into that problem that you can't open another file because you have too many open. So it's always good to remember to close your files. Okay, prior to the C11 standard, the file name had to be a C-style string. Since C11, it can be a C++ string. What that means for y'all is that if you're using that C11 flag to compile, you're fine to use C++ style strings. But if you're not, then it's not going to work with C++ strings. And in that case, you would have to say dot open with the file name .c_string in order to extract the C style string. So if you are not using the C11 flag for compilation, you will need to use .cstring to extract a C style string from a C++ string. Okay? And for OF streams, it's the same. So you open the file name with the same caveats. You write into it with the less than, and you also close them. Okay, you don't have to give the file name when you close. It knows what the file name is. They operate just like CIN and COUT, except when you're, let's say that I have an IF stream, foo, I would read from foo. I would say foo into whatever my variable is, rather than CIN. So you use the name of the file stream to do your reading. You always check to see whether the open failed or not, because there are at least two reasons why the open may fail. Can you think of what those two reasons for failure are?
Doesn't exist or you don't have permission.
Very good. Doesn't exist or you don't have permission. Two reasons it might fail. So you should always say something like if foo.open, or not actually, so if not foo.open, file name, and if it doesn't open, some error action. And the book has another way of doing it. That's fine. Open will return false if it fails, true if it succeeds. Okay. There is a helpful error, so you're never sure what the reason is. So you can use there is a command, perr, prints the reason for a system error. So perr standing for print error, it will print the reason it failed. Okay, so let's just do that. Give that a whirl. So I'll call it f.cpp, include fstream. So I'm going to create an IF stream, call it input file, if input, if not, input file.open brad, say brad.txt, perr, brad.txt, and return 1 to indicate failure. Okay, so all I'm doing, I think I'm going to have to find the library for perr. So I want to see if it works this way or if it's going to give me an error message telling me that I need to invalid. Oh, really? Open doesn't return? That's what it's looking like. Let's check that out. So whenever you have a question about something, CPP reference is always a good place to go. So CPP reference file open. And indeed, it returns void. So my cute little way of doing it doesn't work. So we're going to have to do it the way the book did it, which is to use the isOpen. So the book used isOpen. I will do that too. So first of all, I will open, and then if not input file dot isOpen, And that seemingly worked. So let's run it. Okay, brad.txt, and you can see it printed no such file or directory as the error message. Now I'm going to create brad.txt. The touch command does it, and it worked properly. Now I'm going to change the permission so I don't have permission to read it. So the 000 makes sure I don't have permission to read it. Brad.txt, permission denied. So p-error will tell you what the error was. And the brad.text actually is what gets printed beforehand. If I did not put brad.text there, I would get an empty. It's just telling me what file it failed on. So here it just says permission denied, but it's not very helpful because I don't know the name of the file. So normally when you call p-error, after a failure, you give it the name of the file that it failed on, and it will print that out along with the failure message. Okay? Any questions about file I/O? It's pretty straightforward. Okay, I will, before y'all take off, will say one thing because eventually you're going to have to use, I'm not going to worry about it now. Yeah, I'm not going to worry about it now. Okay, going to let you go. So, I guess on next week we are going to cover procedures and functions. So very quickly we're going to start running out of stuff you're familiar with and getting into stuff you're not familiar with. Now I will also tell you, you think 2D vectors look pretty easy. They will be the first thing that start to confuse you. We just know from previous labs that V-flip is probably going to cause some of you some issues. So get started on that lab a bit early and make sure that V-flip, you get it done.